This is Honors Pre-Calculus Final Exam Review 2013, number 43. Number 43 talks about a painter who's covering a triangular region, and that triangular region has certain sides. It tells about a can of paint covering a certain number of square meters and asks how many cans will be needed. So the first thing I need to notice about this problem is that it is a problem about area, because if I'm trying to cover something with paint, that's the meaning of areas. How much how much two-dimensional space can I cover? Also, when I see that we're talking about square meters, that tells me that I'm talking about area. So I'm going to think about area and the fact that I'm given three sides. So we have two different area formulas that we've been working with in our pre-calculus classes. One is area equals 1/2 AB sine C. And one thing unfortunate about this layout of the formula is that the A here usually stands for an angle, but this time it means area. So that's one formula. And the other formula is Heron's formula. Heron's formula. And Heron's formula says that the area of a triangle is equal to the square root of S times S minus A times S minus B times S minus C, where the S is equal to A plus B plus C over 2. So we need to pick which of these two formulas to use. And the important thing that we want to notice about this problem is that we're given the sides of the triangle but none of the angles. That means we can't use this formula. Actually, you can use this formula by using the law of cosines first to find the angle, and then you can use this formula. But that's probably a lot of extra work because you need to use two formulas. Heron's formula, we can use this formula, and it's a difficult formula, so it's a little, but I think this is a little more direct to use Heron's formula. So the first thing we're going to do is find the area of the triangle. Let's write down our given information, our different sides. They're A, B, and C, and it doesn't matter which one is which. So we're saying A is 64 meters, B is 67 meters, and C is 73 meters. Now I can find the area according to this formula. The first thing I need to do is find out what S is. So I first start by saying what S is. It's 64 plus 67 plus 73 over 2. So let's find out what that is. If we do the top of this as if we do the whole thing as one statement and keep the top as a fraction, so we'll need to keep that top in parentheses. 64 plus 67 plus 73, close parentheses, divided by 2. Of course, you could also just calculate this sum separately and then divide the result by 2. So I get 102. And my S is 102. And now I can go into this formula. The area is equal to the square root of 102 times 102 minus 64 times 102 minus 67 times 102 minus 73. And I can type that all very directly into my calculator. So I can type exactly all of this. So we'll start with square root, so square root of 102, and I can just put parentheses, I don't even have to put times. 102 minus 64, close, open, and then we're here, 102 minus 67, close, open, and then 102 minus 73, 102 minus 73, close, and that's it. Now this should give me the whole shebang. Sometimes when I type a long formula like that, I like to go back to the beginning and check it over. I've got the square root, I've got the 102, 102 minus 64, 102 minus 67, 102 minus 73. Yep, it's all there. It looks right. So I'll just press enter, and it gives me 1,983.46. So let's call it 1,983 since these were all given to no particular number of decimal places. 1,983, and this is square meters. So this tells us that the area of this triangular region, that's what it is, it's a triangular region. We don't know if it's a region, what it is a region of. Maybe this is on his kitchen floor. This painter is going to paint a big triangle on his kitchen floor and then fill it in. It's just a triangular region. All right, the area of that triangular region is 1,983 square meters. We don't have to remember to take the square root at the end because we did the square root at the beginning. So we don't need to worry about doing a square root at the end. Now, the question, though, is not what the area is. So I got the area here, but I have to pay attention to what the question was. The question isn't what the area is. The question is how many cans do I need? And it tells me that one can covers 70 square meters. So if I know that one can covers 70 square meters, and this is how many square meters I have, it should be fairly clear that I need to divide this number by the 70 in order to get the number of cans. So I'll do my number of cans equals 1,983 divided by 70. And on my calculator, I can just take my answer that I already have, go divided by 70, and I get 28.33. So I get 28.33 as my number of cans. But this painter, we want to know how many cans he needs. Well, we could say he only needs 28 1/3 cans. But if he's going to the store to buy cans, he can't buy 1/3 of a can. So we'd probably say the painter needs 29 cans. Of course, if you were to round this to the nearest whole number, you'd round it down to 28. But then as a painter, he's going to be short 1/3 of a can of paint, so he better get the 29 cans. And that is our answer to number 43.